waiting. This is going to be a short live unless we have many people. So I'm just going to make it simple and short. So today's topic is different. Um, some time ago, I wrote an article on landsports.com, formerly phpocean.com. I think it was then when it was phpocean.com. I wrote that article, which is learning programming is different from learning a programming language. So this is what brings us to the topic today. Today's topic, which is coding or programming. So that's what I would like us to discuss today. So if you are around, please try to invite other people. Try to invite other people, and let's discuss this matter today. So I will share coding or programming. So programming or coding, that's today's topic. So um, we are 7 minutes in. Let's hope we get somebody at least. So in the worst scenario, no problem. We'll still get. We'll still have to make the live so that later on you guys can replay it. Okay. So we're waiting for the 7th minute or so. So that's 8. So by in 10 minutes, that's in 2 minutes. So we'll go to 10 minutes. We'll have to go. Have to start. So probably people will join as we go on. So we are waiting. We are waiting. We are waiting a little bit more. Okay. So I think we are up to we've waited for 10 minutes and that's quite okay. So welcome again to this show, another Sunday, another computer science show with your host Ahmed Salifu, aka Zubuli. So today I would like us to discuss something simple. It is not really a deep topic, but I would like to underline the nuances and also to help new learners to know what they are doing. So you shouldn't come and be saying, okay, I'm a programmer, and then you are missing some crucial parts of programming. So because of that, we'll start from understanding the meaning of some of these words This is our jargon in programming. So we have the word coding and the word programming, right? So that's what I mentioned in the discussion, coding and programming. So the word coding, I went through to search a little bit about coding and coding and so on. So in their etymology and so on. So we have here etymology of encode, and then the etymology. Let me search for code. Etymology of code. So yes, like this and so on. So we'll start from the word code because it is very important. So here it says that the word code emanated from the Latin language, which and it was then like codex or codic. Okay, codex or codic, and then it moves on to French and then remain code, and then English too. It became codex again. So via the Old French from Latin codex, coding, and so on, the term originally denoted a systematic collection of state ah man, so of status, right? So status is basically made by just Justinian or another or blah 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 and so on. Compare with code, since three of the known cab. This is a lot anyway. So basically, the word denoted, that's the part we are interested in. The term originally denoted systematic collection of statuses. Wow, statutes. This is strange. So basically, what I understand from the French perspective, what I understand with the word code here is like something hidden, like something special. The word code here stands for something hidden or special that is not only that is not accessible to everybody. So basically, it's a secret. So if I say, for example, the code of our business, so that's like the secret trade. It's our secret trade. The same thing if I am to say, okay, I hope I'm sharing. Yes, if I'm to say, okay, what is the code that unlocks your car? So it's like the secret key, the secret part that actually unlocks your car. So basically, the word code here is to say something hidden, something special, something that is not always accessible, right? And that is also it is something that is required, something that is needed, specifically needed to make something specific. So if you don't have the particular code, you cannot you cannot take a certain action, or you cannot have a certain thing. So that's what I understand there with the word code. So if we move on, we check the word in code, and here the prefix in says make, to put in. So you can see, so when we decide to take something and then we encode it, so we actually change it into code. So whatever we take, we encode it, we change it into code. And I used to take these examples. I used to take the example of HTML, for example, and when they give you a design and they say, okay, you have a button here, you have a form here. So this particular design has to be encoded. So it has to be transformed into a code. So that's an example of how we can use the word encode. So now we understand the term code and then the term encode. So let's see, why do we speak of coding as programmers? So if I go with coding right now, you will see automatically they will just start talking about computer programming. So it says here coding, also known as computer programming. So the word coding has automatically been synonym of computer programming, and we are not there yet, because I want us to look at the word coding itself. Etymologically, what does the word coding mean? It's basically like encoding. It's the process of making a code out of something, right? It's the process of making something making a code of something, right? So you take something, you start transforming it into a code, and that process is called coding or encoding. So we are either coding or we are encoding. And another real life example is when you have your decoders. TV decoder encodes and decodes. So it encodes signals and decodes signals, right? So when it receives a signal from the source, it decodes it and then make it accessible to your TV receptor. And at the same time, if your TV receptor or your decoder has to uh, respond to the source with another signal, it has to encode it and so on. So in terms of encoding, there's this feeling of hidden, there's this feeling of hidden thing. And indeed, when you look at programming languages today, it seems like, yes, it's a language to hide some knowledge. It's an alien language, so it hides something. Anyway, that's a bracket. So now we have seen what code is, what encode is, and what coding is. So what does that have to do with computer programming? So computer programming, if we check Wikipedia, it says computer programming or coding is a composition of sequences of instructions called programs that computers can follow to perform tasks. So basically, we write some instructions. We write a sequence of instructions in a particular manner, coding, right? So we kind of prepare a set of instructions that the computer can understand. Because when we're talking about coding, when we're talking about code or encode, we did not specify who is the receptor of the final code. So in this case, it goes straightforward. The receptor here is the computer. So once we encode these instructions, once we arrange them in a given way, so our code, then the computers will be able to understand and perform given tasks. So that's what that means. So programming as well. Let's look at the word programming. I think once we have all this added together, it will make more sense. Sorry again. So what is programming? Let's look up programming. Etymology. So the word programming from Greek pro, before, graphene, write. Then it went to Greek again, it became prographene, write publicly. Then in Greek again, it became programmer. Then Latin, it crossed Latin a little bit and became program, which is written notice. So early 17th century, in the sense written notice, via late Latin from Greek programmer, from prographene, write publicly, from pro, before, graphene, write. So, um, this sounds like there's not much we can get from the word. Oh, did I search? Yeah, search programming, not program. So, if it tells us about program, yes. So, program is actually a public notice. So, it says it is a notice, it's a written notice. That is very important because here we write. So, it is a written notice. That's a program, a written notice. So, it means if I have a file which contains, let's say, some code or some encoded information, then I could call it a written notice, right? And I guess the word programming now is actually the English way of telling us the process of writing these programs. So that goes to join the word encoding, right? So the word encoding is about programming. But today, if we look at the actual English of the word program, it is broadly used in different angles. So if we look at the book structure and structured computer program or something, structured computer program or something like that, from Professor Susan or something like this. In the introduction, he makes us understand that It's not only computer scientists who program, but we also have armies, teachers, parents, and so on who program. So it becomes like a way of defining or instruction an object or an entity to behave a certain way for certain reasons. So this is actually programming. So it's not necessary to how do you call it, to write computer programming. So programming can go broad, and that's where in all these researches I was making right now, I was doing right now, you can see that Google always adds computer programming, computer coding, and so on, because we have to be specific what we are doing. Are we doing computer programming or that programming? So you see the idea. Although encoding, programming all mean the same, which is to kind of create a code, a specific code that can be understood by specific object or entities for specific reasons, but still programming can be broad. It can be broadened to other areas of life, not only computers. So it is very important to always specify that we are talking of computer programming, right? We are talking of computer programming. So now let's discuss the next part of this problem I have with the programming, and that's what I'm meant by I want new learners to understand what this is all about. And that brings me to the article I wrote earlier on, which is the difference between learning programming and learning a programming language. So programming, now we understand that okay, we have computer programming, we are doing computer programming. I would like you to notice the difference that, between you learning the programming language and actually learning the program, right? Learning the programming and what you learning the programming language, what I call coding, because remember, encoding is just transforming problems into a code. So when you have a problem or a website or a project or any application need, and they say you transform it, they bring you the mockup, the structure and other thing, then you transform it into code, does not necessarily make you a programmer. Remember, from the broad definition of the word programmer, programming is a whole process in its own in in instructing objects or entities to perform specific tasks. So that process of instructing entities is a whole scientific process that include mathematics, physics. Oh no, I don't think we have to go to physics. Mathematics in its many branches, so including calculus, algebra, uh, many other fields in the mathematics, even to pure math, and so on, including probabilities and statistics and so many other things. Then you have logic here and there and so on. So all these sciences combine help you to be a great scientific scientific programmer. So it's not just about writing the code, but it's also about having the tools to reason properly, to reason scientifically. That's what I'm talking about by saying there is a difference between being a coder and then being a programmer. Programmers are not only coders, but they are also scientists. Let me repeat that again. Programmers are not only coders, but they are also scientists, because coding is just a way of just translating a problem or a situation into a code. But a programming is a process in instructing an entity to behave a certain way. And that requires a lot. And that's where the science comes in. So this is the discussion I wanted us to go through. And if you read this article, I mentioned some of these issues inside and give some examples. So you can see here an example of code written in different languages. Because for the programmer, what he sees is the solution. The programmer sees the solution, not the implementation. The programmer cares about the solution. And that's why, as a computer science student, you'll be disturbed with mathematics and so many other tools to use to reason. So these tools are there to help you think, come up with solutions, implement, and then you can now implement these solutions in any language you want. So here I implemented this same code in like 4 languages, right? So in C, PHP, JavaScript, and then scheming. So if you take scheming here, for example, I don't know how to program in scheming per se, but I could just write with a little bit of research. I could encode my problem, which is the square function, into scheming. And the same thing, I don't need to know JavaScript that much. With a little bit of research, I can implement this. But the idea or the process of coming up with that algorithm, that logic, which is the square of the number, that requires science. And that's where you have to pay attention as a computer scientist or as a computer science student. So that's what I wanted us to discuss today. And it's going to be a short live. So I hope you've learned something out of it. If you did, please leave your thumb up, share the video with some other friends and other people around you. The word will be spread around. So thank you for being around. If you pass by, and we'll meet on Sunday, next Sunday, so that we can discuss other topics. So I think next Sunday I'll try to publish the topic before the time. So I'll prepare the link and other things and share it before time so that everybody will get time to prepare themselves and join the live. So I hope this helps you and see you in the next live. Thank you for watching.